Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Starting from this video, we are going to solve a number of problems on a line inclined to both the planes, right? Each problem is taken as a separate video. Do like, share, and subscribe. Next. So let's take a problem here. Line AB is 75 mm long and is 30 degrees and 40 degrees inclined to HP and VP respectively. So theta is 30, phi is 40. True length is given, true inclinations are given. A position is given. Let's represent the data. Take the reference line. We have drawn a reference line for projector here. 12 mm above HP. That means this is 12 mm. A dash is marked. 10 mm in front of VP. On the same projector at a distance of 10 mm, we mark the point A here. So we got A. Now let's represent, take the true length and assume that the line is parallel to VP first. Okay. So the line is parallel to VP. That means in the front view, we see the true length of the line at 30 degrees angle. So at 30 degrees angle, we draw a line here of 75 mm long. We call it as B1 dash. Okay. Now, here the observations are: draw the locus of B in the front view. Okay. And draw projector onto the reference line. And the top view of this line is also known. So this is AB1. AB1 is the length of the line in the top view. And this is the locus of B in the front view. So these are the observations in one position. Next, let's take the line in the second initial position. That is the true length of the line is taken and 40 degrees angle with VP. The line is assumed parallel to HP and making only angle with the phi angle with or 40 degrees angle with the VP. So this is AB2, second position. Now, we know the locus of B from this position, we get the locus of B in the top view. Now, draw projector and also we can mark the front view of this line AB2. That is A dash, B2 dash. So A dash, B2 dash is this is the line parallel to HP. So this is the length of the line in the front view. And that is A dash, B2 dash is its front view. AB1 is the top view length. That's it. And also we mark the locus of B in the front view and top view. Next, let's rotate this line. A dash as center, A dash, B2 dash as radius. B2 dash is moved upwards as if B moves as if it is an arc of a circle in the front view and is moved up to the locus. So this point is B dash. Now A dash, B dash is the front view, final front view of the line, and we call it as front view here. You need not write it. For your understanding, I have written. And this angle here, the front view makes or appears to be at alpha, apparent angle alpha. Next, draw a projector from B onto this in the top view, right? The intersection of this projector and the locus is nothing but the B, the top view of point B, because B and B dash must lie on the same projector. So join AB, that is the final top view of the line. And so this is, we call it as top view. And this top view appears to be at an angle beta here. So this is the beta in the top view. Alpha and beta are apparent angles. This is A dash, B dash, and is the front view, final projection of the line in the front view. AB is the top view. So we are able to get the final projections of the line. Hope you had understood this topic well, and let's see another problem in the next video.